Don't look back, we're here to stay. A life we knew would come one day. And this is it, the borderline to where the future leaves us behind. The fire will burn and never die, looking through the eyes of a brand new life. And so just find me, just find me. Sparks will fly if we scream no. This is not how we're gonna go. We are the ones who will never let go. Just watch us run to where no one knows. We'll never grow. We'll never grow. Don't look back, we're here to stay. A life we knew would come one day. And this is it, the borderline to where the future leaves us behind. The fire will burn and never die, looking through the eyes of a brand new life. And so just find me, just find me. Sparks will fly if we scream no. This is not how we're gonna go. We are the ones who will never let go. Just watch us run to where no one knows. We'll never grow. We'll never grow. We'll never grow.
So, hello. 10 minutes break is over. Yeah, got myself a little bit of water. Now we are going to implement our representation of mathematical terms in Swift. This should be a little bit quicker, I think a lot quicker than the last 2 hours. So I think I'll need like 30 minutes or a little bit more for this. Let's get started. So we are here back in Keynote, and this is the hierarchy that we are going to implement. And we will start step by step and try to build this hierarchy from the most simplest part to the more complex parts. And I think we're starting with operands, because for operands we don't need actually to have a what is it called, a protocol. We just start with a struct and our own little data type called operand. I already started a new Xcode playground, and we start with operators. So this is a little bit of a Xcode stuff, which will be useful when after we copy this part of the code back to our UI Xcode project. But I want to do this in Playground as well, so that we can play with it a little bit. After, in the next session, we will use the Playground again, I guess, and the session after that we will copy our whole logic back into the Xcode project and connect it with the UI. So what is an operand? Sorry, operators is wrong. Operand. An operand is basically just a struct with the name operand, and it has one value, one unchangeable value, one property, which is called value, and we will calculate everything using doubles. So we have the ability to have decimals in our calculations. And that is basically it. But when I'm using my operand now, if I want to define an operand, like op is operand, you will see there's a default initializer created by Swift, which looks like this. And we can op value, we can get the value from the operand, so that we can get the value back. So which version of Xcode are you using? I'm using Xcode 9, so the newest version of Xcode, which was released with the release of iOS 11. So, but I don't want to have these named parameter here, so I will implement a new initializer, which is basically doing the same as the default initializer, but without the named parameter. So we have a little bit more concise writing of initializing our own data types. So init underscore for omitting the name of the parameter, value double is self value equals value. So this should be really familiar to you if you followed the last session. And now I can write operand 5. Operand 5 is just a 5, and it encapsulates the value 5. Okay, this is our operand for now. So now let's define our first operators. So when you look at our keynote, you see that we have multiplicative, additive, unary operators, binary operators, which are operators. So if you look at this, and you can like say that a multiplicative operator is a binary operator, which is an operator again, you will see that we have there some kind of hierarchy. And protocols actually are creating this type of hierarchy. So what I want to do is I want to have a protocol named operator. Okay, I want to have a protocol which is an operator. Why do I want that? Because I want to store or handle different stuff on operators the same way later when I'm calculating stuff, and different than I do it on operands. So this is actually like grouping our subtypes, sub-data types. So there's a kind of an inheritance going on in this hierarchy, differently than I do with the operands. So it's like a grouping of this, or representation of this hierarchy tree here. So we have a protocol operator. Then we have binary and unary operators. So let's go on and try to implement our unary operators, the first unary operators, because they are the simplest. They just have one operand and they would do something with it and return the new operand, so the new value if you want to. So let's do it, and let's say that we each unary operator is an operator. So this says that our unary operator protocol is conforming to our operator protocol. And a unary operator has one function. We say that the unary operator, every struct or every struct that conforms to our unary operator protocol needs to implement one function. And this is the func eval, short for evaluate, which takes one operand of type operand. So a unary operator, as I told you in the beginning of the last session, is basically an operator which takes one operand and does something with it. For instance, if you have the plus minus operator, it either negates a positive value or negates a negative value, making it positive again. So let's start with that. Now this is all abstract, so there's no actual code. This is just telling what there should be. But now we are actually implementing some logic here. So let's go on and implement our negate operator. So struct negate should conform to the protocol negate operator. So when I do that, Xcode will tell me type negate does not conform to protocol unary operator. That is because we don't have implemented a function called eval by now. But this is actually the contract we go in if we say that we want to be a unary operator. So we can click here and do you want to add protocol stubs? Of course, fix it. And now you see that Xcode added this empty function to our negate operator, which is basically conforming now to our defined function up here in line 18 to have an eval function with one operand. So what is actually happening here? Oh, sorry. I missed something here. I forgot. Our eval function should return an operand as well. So when you have 5 negated, it's minus 5, which will return a value, an operand, with the value minus 5. So what we do is we return, if you want to return something from a function or a method in this case, you use the return keyword. This way you can return a value back from the function to the calling code. Hope that makes sense. I let this out in the basics, but this is a good way to show it actually. So if we want to return an operand, and this operand should have the operand value, but minus. So this operand, we get the value of it, put a minus in front of it, and return this. And this should be returning an operand. Okay, let's try that out. So that's why we are on the playground here. So we are creating an operand here. Let OP equal operand 5 again. So we get our own data type called operand, which encapsulated the 5. And now we want to use negate as an negate on that operand. In our representation, we need an operator here. Let's call this operand and this operator. Okay, operator is a saved word, so let's call this operator with a 0, like lead, and give it our custom type negate, which has no properties, so no initialization parameters. And now let's evaluate our operand using our operator. So operator dot eval with our operand, and this is calling our evaluation function, passing in our 5 wrapped in an operand, and it returns an operand. And if we can now dot value here because this part of the code is evaluating to be of type operand, we can then dot access the property value, and we see that we get a -5. So that is actually working. Our first operator, negate, is working. Let's go on because it's working so good so far. Let's implement our second operator for our calculator, which is the %. Let's call this % Unary Operator. Let us help. Let Xcode help us. And what we do now is we return an operand, taking the operand value times 0.01. So the % operator is nothing more like divide by 100 basically. So let's try this down here with our operand 5 and replace the operator by % instead of negate. Now our operator evaluates the operand to the value of 0.05. Okay, I hope that makes sense. So this is the implementation of our first negate and % unary operators. So you might say, why do we need all this protocols here? We could just implement negate, evaluate, % evaluate. True. But in the end, we want to have a list of operands and operators so that we can write out a term like 12 times 256 minus 8 divided by 3. We want to store this different tokens here, operand, operator, operand, operator, operand, operator, operand, in one list of tokens. That is actually why we need this this common protocol for all of our hierarchy here. So one thing we have to do is to have a protocol token in here, basically like this empty protocol operator, and make an operand to be a token, and operator to be a token. So there's a question, Starlord91. I will come to that in a moment. Let me just finish that here. So what we want to do is we want to be able, if we have like this equation here, -5, we want to write this in form of a term. We want to have let term be a list of five. We enter a 5 on the calculator, and temp on the negate button. We want to put a negate operator in our list. So this is actually later. Sorry. We have to wrap this around an operand here. So in order, just check. Operator is token, operand is token, so term is of token. So we can now write our term to be a list of operands and operators, or basically just tokens, which we enter on the calculator. That's why we started with the calculator 101, to get you now to the idea why we do this. So when we're starting writing a number, we write the number, we save the digits, and as soon as we hit a operator, we will save this number to be an operand in the list, and after that we save the operator into the list so that we can save the term. I hope that makes sense. So, Starlord91 is asking, is 0.01 the smallest value in Xcode, which we use for percentage? I'm not sure if I get the question correctly, but 0.01 is not the smallest value in Xcode. It's not the smallest value. Xcode is more, so there are different stuff here to distinguish. So Xcode is an IDE, stands for Integrated Development Environment. So this is not that's basically just the tool that helps you to program stuff. Swift is the programming language you use in Xcode. So you use Xcode to program in Swift, which is then compiled to be a program on your machine. So the lowest value a program can use is down to the hardware your program is running on. So you have this different parts in your system on the computer, like you have a CPU, you have a central processing unit, CPU, you have a GPU, graphics processing unit, or graphical processing unit, and all these different processes are having different limitations in storing numbers. And actually, the smallest number for a float, for instance, or the data type float and double are determining the lowest number depending on how many bits your system supports. So for 64 bits, it's a smaller number. The smallest number is way smaller than it can show on a 32-bit system. So this is a lot of technical stuff that doesn't really matter right now, and it would like burst the frame of this course, but just so that you understand that the question you're asking has different layers to it, which we use for percentage. For percentage we use 0.01, of course. because if you type in 1, and 1% is 0.01. So let's say if you have a number like 50. No, okay, 50 is stupid. Let's make it simple. If you have 100 and you want to have 1% of 100, you can type 1% times 100, which gives you, in our evaluation, 1% to be 1.01 times 100 is 1. So 1% of 100 is 1, which makes sense because that's basically the definition of percent. 1% is 100 still. So I hope that makes sense then. So we have the unary operators and the negate and percent operators we have. We can write it like this, and we have a way to store it in a list of operands and operators. So let's go on. We have now our multiplicative and additive operators, which are both binary operators. So what I want to do now is to create a protocol for binary operators. And this is not conforming to unary operator because they are on the same level, binary unary. They are both conforming to operator. So the difference between a binary and a unary operator is that the unary operator just takes one operand, whereas the binary operator takes two. So our eval function for the unary operator is not working for our binary operators. We need a new eval function. I just copied this down here and say that we have a operand A and an operand B. Okay, cool. But now we can start and implement our binary we can't just start and implement our binary operators, which like we did with our unary operators. We have to add another abstraction layer here, because we have to distinguish between multiplicative and additive operators. Because multiplicative operators have to be evaluated first before we can use the additive operators. That's because we have a different, we have a certain order of operations that we have to do. So multiplication and division have to be always evaluated before subtraction and addition. So we add another layer of protocols here. We have a protocol let's start with the stronger one. It doesn't really matter, but it's my taste. Multiplicative operator, which is conforming to the binary operator. It's just an empty protocol. It's don't adding new kind of information. It's just grouping. And you will see next session, so next week, why this is important. I will reference back to this a lot, and we will talk about this. And maybe something might be a little bit, seem a little bit over-engineered to you now, but bear with me, you will be understanding it next week. And we have our additive operator. So let's implement them. So we have the multiplicative operator, of course, the multiplication. So we call this, now we are implementing again, so we don't use the struct. The struct is just defining the different stuff that is equal and grouping the stuff, but really implementing, we use our structs. So multiplication is a multiplicative, of course, it's a multiplicative operator. So Xcode will tell us that we have to conform to the protocol in just a couple of seconds. And it does, but it's not showing here, so I just help him. I copy this, put it in here, put it in there. So how do we multiplicate two operands? We just do A value times B value and wrap this result again in an operand and return it. Easy. And the same we do with the division. It's multiplicative operator as well. We do all the same, but just doing the division in there. That's easy. So let's test them out real quick. So let's do a operand A and an operand B in here, like 3. And let's try out our operator to be a multiplication. We add the plus, operand 5 times, and after that 265. And this should actually evaluate to be 1337. Okay, this needs to be explicitly to be a list of tokens. And yeah, that's basically how we would represent this equation inside of our representation. How would we actually calculate that? That's the topic of the next session. But I will show you really quickly how we can do this for this specific example, how we can build the right calculations, but to make this work for every type of combination we can type into this list, we have to implement something that is called an LR parser, and we will implement that next week. But let's really quickly calculate and see that our representation can actually calculate what we want it to be. So we can do the following. We take the percent. So this is 0, 1, and these are the indexes. So term. So there's a question. How long have you worked with Swift? With Swift since it came out. So 2015, beginning of 15, right? So 2.5 years, I guess. So we're taking the percent operator, 1. We have to use, we now must make sure that is an operator, a unary operator, as unary operator. So this is a little bit complicated right now, but maybe you can see what I mean. So then we evaluate the operand 1. So we put in 0 as operand. dot value. So let's try this out. So this must be the first step. So 10 times percent 0.1. Then this result here is the first operand of our multiplication. So we have to grab this. So we get an operand back, and we put this into our multiplication, which is term item 2 dot as binary operator our first, and the second half of the multiplication is this operand here. So I write it a little bit different. I see that this is not really speaking anymore. So let's just make it a little different. Let's define, we need a percent to be percent. We need a multiplication to be a multiplication. We need a addition, and that's it, right? Yeah, addition. So to build this kind of, or to evaluate this kind of list, what we have to do, just really simple here. We will go into this more in detail next time. Percent eval, and getting the operand here, operand of 10. And this is the first operand of a multiplication, A, and the second is an operand 120. So this here. This is all part of an addition, where the first part is this multiplication and the second part is another multiplication. So we put in a multiplication, eval 5 operand 5 and operand 2, 6, 5. And this must be eval. Okay. Making all the brackets right. Checking if this is working. Let's write it a little bit different. The addition. Percent. This is wrong. A. B. And let's write this a little bit clearer. This is the end of the multiplication. So let's see if I can make it this way. Write it up a way that it is actually easy to see that this is a good way to represent the stuff. Good, I think this is a good way to see what is happening and to see if that is really the right result. We will put in value and we see that this term here is evaluating to 1337. So let's go through this a little bit more. So what we do first is we have this addition here. But this addition can't be calculated unless we calculate the multiplication on both ends first, because they have to be evaluated first. So we have a multiplication here and I have a multiplication here. So the second one has just operands 5 and 2, 6, 5. So we can put them in here. The first one has a unary operator here, which is applied to operand 10. So we have to put this in for the first operand calculation of our first multiplication and multiply this with 120. And then we can use this result from this multiplication and this multiplication to add it up and get the end result. Okay, bam. That's it for today. I'm done. We have a nice representation of mathematical terms in Swift. We have seen how we can use it to actually calculating stuff in a really lengthy and typing intensive way. So this is actually not, I wouldn't do that to write your common whatever math terms in your Swift programming, but this is actually something we need to interpret the entries to the calculator correctly and to give the right result. Okay, I'm done. I guess you are done. You have a lot to think about. I will save this up, put it into the zip file and upload the new zip file right away after I done with the stream. So, if there are any questions left, now's the time to ask. If there are any remarks you have on how to make this better, now's the time to say them. If you like what you saw, please feel free to subscribe and and join me next week again here, and then we will use our representation to actually interpret real lists of terms. You will see how this works, and I hope I will get through this in 1 hour next time, not use up too much of your time. Thank you very much for the compliment. I'm glad you liked it. So I guess there aren't any more questions, so I say have a good night, have a good day, have a good morning, depending on when you watch this and where you are right now, and see you next week. Bye.